Okay, this word here is very important. Okay, then your negative angles they are measured from the x-axis in a clockwise direction. Okay, this is going to become more important next year. For now, you need to be aware of the fact that your angles they can be negative. Now, if you have got a Cartesian plane, it means if the angles are positive, they will be measured from the x-axis in an anti-clockwise direction. So the positive case is like this. If I draw my Cartesian plane like that, and if I put a terminal ray, this is what it's called a terminal ray. It's a line drawn from the origin, okay, on a Cartesian plane. So if theta is like that, it's measured from the x-axis and the direction is anti-clockwise, then theta is going to be positive. So here, theta is going to be greater than 0. Okay, I'll put 0 degrees here. Okay, so that's the positive case. Right, then the negative case is when you measure the angle like that. If the angle is measured in a clockwise direction, this becomes minus theta. So here, theta will be less than 0 degrees. Okay? Yes. The right angle triangle. That's what I'm doing now. So if I draw that terminal arm, then if I draw a line perpendicular to the x-axis, like that, I'll end up having a right angle triangle. Okay? Then obviously this is my y, that's my x. Okay, and then this angle, I'm gonna call it theta. Okay, and the length or the radius of the circle, I'll call it r. Okay, it is denoted by the small letter r. It's called the terminal arm. Okay, then this point here, we have an x value. The length from the origin to here is x. Okay, let me. Okay, this length here from here to there is x, because it's along the x-axis. Then the length from here to there is y, because if this line here is perpendicular to the x-axis, it means that it will be parallel to the y-axis. Okay, so I can extend that this will be like my y. Okay, please note that the point x is the value of x here is x, the value of y here is y. So this point here, we can call it point xy. Okay? Now, once we have that, then we can bring in our trigonometric ratios. Because we have a right angle triangle here. Okay? Our reference angle is theta. So this side here becomes our opposite side. This y becomes our opposite side, and the x becomes the adjacent, and the r becomes the hypotenuse. Okay? Let me just put it h there. So this becomes h. Okay? So we go back to trigonometric ratios. Okay? Right? So from trigonometric ratios, sine theta is equal to opposite over hypotenuse. So from this diagram, okay, inside that right angle triangle, my opposite side is y, my adjacent is x, my hypotenuse is r. So my opposite is y, and my hypotenuse is r. So we are going to get a new formula on trigonometric ratios, but it will be in terms of a new set of formula in terms of x, y, and r. What? Because I'm saying this is my reference angle. y is going to be my opposite side, which means the hypotenuse is going to be h. So sine theta is going to be y over I over h. Then cosine of theta, x is the adjacent. Okay, x is the adjacent. The hypotenuse is r. So here it's a over h, which will be x over r.
When we find the angles, then we use the shift.
Yeah. Yeah, if you find the angle, use the shift.
Then y is that? So y is the.
We are applying knowledge of trig ratios on a Cartesian plane. Your trig ratios, sine theta is opposite over hypotenuse, cos theta is adjacent over hypotenuse. This is a right angle triangle. Okay? If this is the reference angle here, the vertical distance is y, the horizontal distance is x. Sine theta opposite over hypotenuse. Yeah, so y over r. Cos theta adjacent over hypotenuse. This is the adjacent is x, the hypotenuse is r. Please don't complicate things. Don't complicate things. By now, I expect you to be familiar with trigonometry, sine, cos, and tan. The only thing is that we have got a right angle triangle on a Cartesian plane. Okay? The vertical distance is always y. The horizontal distance is always what? X. There is no need to complicate that. Okay? Alright. Then tan theta is equal to y over x. Okay, perfect. I suppose right there, opposite over adjacent. So it's opposite over adjacent. Which one is the opposite side? It's y. With reference to this theta, remember the theta is measured from the x-axis in an anti-clockwise direction. Okay? So theta is our reference angle. Therefore, this vertical distance y becomes the opposite side. And the x, which is a horizontal distance, it becomes your adjacent side. Okay? The radius of the circle becomes your hypotenuse. So this will be y over x. Okay? And then we can introduce the theorem of Pythagoras here. It's a right angle triangle. The hypotenuse is r, the vertical distance is y, the horizontal distance is x. So if we use the theorem of Pythagoras, we end up having r squared, which is the hypotenuse, is equal to x squared plus y squared. Okay? Now, this set of formulae, these four, are very important and geometric. Very important. Okay? So from now on, you need to know that your trigonometric ratio can also be used on a Cartesian plane. Sine theta is equal to y over r. Cos theta, x over r. Tan theta, y over x. If you use the theorem of Pythagoras, r squared is equal to x squared plus y squared. Okay. Right? Here, I was just introducing, okay, and relating the Cartesian plane to trig ratios. So we need to know that the r squared is equal to x squared plus y squared, theorem of Pythagoras. Sine theta is equal to y over r, tan theta is equal to y over x, and cosine of theta is equal to x over r. So this is very important and geometric.
And so you just know that.
This is so.
Right.
This is something you have to remember.
Can I have your attention? Can I have your attention? Alright, if you draw your Cartesian plane, now your Cartesian plane can be divided into four quadrants. You already know that.
Yes.
Right? So from the x-axis, moving in an anti-clockwise direction, we have 0 degrees here, then 90, then 180. We are moving in that direction.
It's 80.
Okay? 90, pay attention. Then 180, 270, then back here we have got 360. So the point where we have got 0 degrees and 360 is the same point. Okay? Then you already know that the area between the y-axis, the positive y-axis and the positive x-axis is called the first quadrant. The one between the positive y-axis and the negative x-axis is the second quadrant. negative x-axis, negative y-axis, third quadrant, negative y-axis, and then the positive x-axis, fourth quadrant.
So why is it
Okay?
always anti-clockwise?
Now, pay attention. Pay attention. Now, your angles, okay? Your three trigonometric ratios, sine, cos, and tan, they can be positive or negative depending on the quadrant. Okay? Sine, cos, and tan can be positive or negative depending on the quadrant. Right, so I'm going to add another Cartesian plane here where I'm going to explain that part. So, this is quadrant 1. That's quadrant, sorry.
Can we use normal numbers?
Okay, let's do that. That's quadrant 1, that's quadrant 2, quadrant 3, quadrant 4. Okay? Can you pay attention? Pay attention. Right, so we've got 4 quadrants. Can you stop it?
Get out.
Alright. Shh. So, in the first quadrant, okay, all 3 trig ratios are positive. So, if you take any angle between 0 and 90 degrees, if you put sine that angle, cos that angle, tan that angle, you always get a ratio which is positive. Okay? Then, in the second quadrant, okay, only sine will be positive. Make sure you pay attention. This is very important.
So you're going to give a PDF,
right? Obviously. Alright, so in the second quadrant, sine only is positive. Cos and tan are negative.
Why?
Alright, take your calculators. Take out your calculator. Take out your calculator. Right, I want you to, let's choose, say, 50 degrees. 50. Right, put sine 50, cos 50, tan 50. You must do it separately, one by one. Sine 50, then you must note the answer whether it's positive or negative. Cos 50, you must note the answer whether it's positive or negative. No, separately, one by one.
Okay.
You do sine 50, then you press equals. You check if the answer is positive or negative. I'm concerned with whether the answer is positive or negative. They are all what? Positive. Now, can you try? Okay, let's move on to the second. So if you try all angles between 0 and 90, you get positive values for the first quadrant. Okay, then second quadrant, let's choose 130, right? Sine 30, sine 130, positive. Cos 130, tan 130, negative. So in the second quadrant, only sine is positive. You can try that for any angle between 90 and 180. Then in the third quadrant, only tan, only tan is positive. So let's choose, say, 220. Sine 220. Sine 220 is negative. Cos 220 also negative. Tan 220 is positive. Then in the fourth quadrant, okay, and then cos, let's choose, say, 300. Cos 300 is positive. Check that.
Yes, it's positive.
Sine 300 is negative.
What about cos 3000?
And then tan, and then tan 300 is what? Negative. Is negative. Then pay attention carefully. Then we can come up with what is called a cast diagram. The cast diagram is the Cartesian plane divided in terms of whether each of the 3 trigonometric ratios are positive or negative. So we take the first letter, starting from the first quadrant, the C, then going anti-clockwise, the A, then the S, and then the T. You can come up with the word which is The word cast. Now, so if you hear me talking about the cast diagram, I'm referring to the Cartesian plane. Okay? If you hear me saying cast diagram, I will be referring to the what? To the Cartesian plane. So this is called the cast diagram. Okay? Right. This acronym is there to just help you to recall the trigonometric ratios in the Cartesian plane. Okay? Do you hear me? The C is for cos. The A is for all in terms of positivity. The S is for sign. The T is for tan. In terms of quadrant, this will be quadrant 4. That's 1, then 2, then 3. Okay? Okay? So it's 4, 1, 2, 3. Okay? In terms of positivity. Okay? Then, so everything, pay attention. What's in this table here? It is based on what I just told you in terms of the cast diagram. First quadrant, all three trig ratios are positive. Second quadrant, sine only is positive. Third quadrant, tan only is positive. Fourth quadrant, cos only is what? Positive. Okay, so what's on this table here, you probably won't need this table if you understood what I said. This table is not very important. Right? The conclusion here comes from the cast diagram. Okay? And so you just have to know that word cast and know your patterns. It's very important. You have to memorize it. Okay? So 10.1, right? 10.1, it will be first quadrant. Okay? Thank you. Let's get on. Then, yes? It's on the what? It's along the x-axis. Okay. Generally, it can be possible, but generally when you are doing questions of this nature, we don't put it on the y-axis or x-axis, but it can be. Right? 10.2, sine theta is negative. Cos theta, yes, we are using the quadrant. We are using the cast diagram. Okay? Sine theta is negative. Cos theta is negative. Which quadrant is it?
3. You guys are listening to me, you're wrong.
Yes, it's quadrant 3. Third quadrant.
When I said 2 and you just asked.
Sine theta is negative and cos theta is also negative. That's the third quadrant.
That's so
right? Then let's move on. I can't do all of them. I'm gonna do 10.5. Then the rest you can do. Right, 10.5. Sine theta is negative, but theta is between 90 degrees and 270.
Wait, hold on.
Now, wait. How many? Okay, wait. How many quadrants are between 90 and 270? 2 quadrants. The what? The second and the third quadrant. So among those 2 quadrants, in which one is sign negative? The third. So this one will be third quadrant. Okay. Are you following them?
Yes.
So I'll stop it. So I'm going to allow, yes?
What? Different.
So let me carry on. Can you stop that, please? Stop that. All right. Let me move on to. Okay. Let me move on to an example. Here, I'm going to take. Let me choose. Let me do this one first. 11.3. Make sure you pay attention and no talking. Right. Now, when you are doing these questions, you may need to draw a sketch. Okay? In the sketch will be allocated a mark. Right? When you are doing the questions, you may need to draw a diagram. Alright, let's start with that question. Right? When you are doing the questions, your knowledge of quadrants is very important for you to carry on. So our trig equation is sine p equal to 5 over 13. So I'm going to rewrite it and write sine p is like theta here, so don't get confused. That's equal to 5. That's 5 over 13. Okay? Then, if you go back to trig ratios on a Cartesian plane, right? Sine theta is equal to y over x. Okay? Then, remember, that's a general formula. Our theta there, here is equal to what? To p. Okay? But which quadrant are we dealing with here? The sine p is positive, and theta p is between 90 and 180 degrees, which will be the what? The second quadrant. Which means our terminal arm or the radius of the unit circle is in the what? Second quadrant. Okay, so we're going to draw the diagram. But before we do that, okay, you need to know that if I compare this and that, we are mainly concerned with y and x. What this means is that our x here is going to be, sorry, I wrote this incorrectly. It's supposed to be y over r. It's y over r. Okay? Our y, if you compare these two, right? Y is going to be 5. And r is going to be 13. Okay? But we don't have x. So to find x, we use the theorem of Pythagoras. So it will be r squared equal to x squared. If you continue talking, I'm going to ask you to go out. And this time I want the question to come back. Okay? Alright. So from here, I write my equation r squared equal to x squared plus y squared. When you are doing these questions, it's very important for you to know all three values. That is x, y, and r. Before you start finding what cos p is, what tan p is, what sin p plus cos p are. Okay? You need to determine all three. X, y, and r. Using the theorem of what? Pythagoras. So my r is 13, so that's 13 squared. My x is the one that I want. My y is 5. So this will give you 169. Okay, and you get x squared plus 25. When you take the 25 to the left, you get 144 equal to x squared. Then this becomes x will be equal to plus or minus 12. Yeah, because x can be negative or positive. We are dealing with the Cartesian plane. Then you draw your sketch. Okay? Where is your terminal arm? Second what? Second quadrant. Okay? So I'll draw it from here. Okay? Then I'll label this y here is positive. It's what? 5. But my x, as you can see, we are on the left-hand side of the y-axis, so x is what? Negative. So among these two here, you take the negative. So that will be minus 12. Then which one is your p? Your p is this whole angle. That's angle p. Okay, yes, the terminal arm can move from one quadrant to the next. Okay? So it means that this point here, it will be minus 12, 5. Okay? And your r is 13. Okay? Generally, this diagram, you are supposed to draw it and you get 1 mark for it. Cos p. Now, cos p, that's 11.1. Cos p is going to be equal to x over r. It will be x over r. What's x? It's minus what? 12. It's easy now. So, this becomes cos p is equal to minus 12 over 13. That's your answer there. Yeah. Once you get your x, y, and r, everything else becomes easier to do.
So I must
It depends. Then 11.2, we want tan p. Okay?
send
Tan p
over
is equal to y over x. Okay? It's y over x. But what is y? It's 5. What is x? Minus 12. So tan p is equal to 5 over minus 12. Okay? Yes. Calculating the x and knowing in which quadrant the terminal comes. Then 11.3. Can you stop that? Listen. Okay? You leave your answers as common fractions. Yes?